Graphing rational functions, section 3, horizontal asymptotes. In the previous two videos, we discussed steps 1 through 6. Steps 1 through 5 focused on stating the domain of the function and finding any vertical asymptotes, which was connected because if you had a vertical asymptote, that was a gap in the x-axis, and so that was a value that x could not be, and that was part of your domain. And the first thing to do is factor the numerator and denominator. Cross out any common factors. Now, if something crossed out, that was still a restriction on your domain. X couldn't be what would make that number 0, but it wasn't a vertical asymptote. Instead, that's what created a hole in the graph. And so that was the previous thing we discussed, was how to find holes of rational functions. Now we're adding step number 7, which is finding horizontal asymptotes. There's 3 ways this can go, and so you got to take this down, and so maybe now is a good time to pause the video and write this down, and I'm going to talk about each of these scenarios one at a time. But there's 3 ways you could or could not have a horizontal asymptote, and the way that the options are determined is by a comparison of the highest power of the numerator and denominator. Highest power, that means exponent. So we're looking at the highest exponent of the numerator compared to the highest exponent of the denominator. Like if you see your numerator has the highest exponent is something x to the third, and the denominator is something with x to the second. That would be a case where it's top heavy, where the numerator exponent is larger than the denominator exponent, highest exponent comparison. And so we're going to look at a scenario of that, but that's when there's no horizontal asymptote. If your numerator power, meaning the highest exponent in the numerator, is larger than the highest exponent in the denominator, there is no horizontal asymptote, and we use HA to abbreviate horizontal asymptote. If the powers are equal, that would imply equal power, meaning the highest exponent in the numerator and the highest exponent in the denominator are the same. Then you do have a horizontal asymptote. Now, horizontal asymptote is like a horizontal line, and it's going to have the equation y equals some number. X equals is vertical and y equals is horizontal as far as linear equations are concerned. And the way to get that's from a ratio of lead coefficients. And that's a little confusing, I think, without an example, but luckily we'll see an example. The third option is that it's bottom heavy, and what that means is the exponent on the bottom, on the denominator, the highest power exponent, is larger than the top exponent of the numerator. And in that case, your horizontal asymptote is simply the equation y equals 0, which is actually the x-axis itself. So first, let's look at a top-heavy scenario. So we're just going to focus on horizontal asymptotes for the first 3 examples, and then we'll do one in the end where we'll go through all of our steps we've covered up to this point, steps from 1 through 7. So notice that in this example, the highest power of the numerator is 3, meaning the highest exponent of the numerator is 3, and the highest power of the denominator is 2. This is a top-heavy scenario. And simply for horizontal asymptote, what that means is that there is not one. And so you would just write horizontal asymptote, none. That's it. Pretty easy. When you see the top exponents larger than the bottom, there is no horizontal asymptote. Scenario 2 is they are equal. So you see the top exponent here, the highest exponent of the numerator is 2, and so is the denominator. So in this case, you do have a horizontal asymptote, y equals, but where we get that number from comes from, I just want to highlight this, the ratio of the lead coefficients. Basically what that means is my lead coefficients are 2 and 3. So I'm going to have the horizontal asymptote y equals 2 over 3. It's the fraction created by the coefficients of these equal exponents. They're both raised to the second power, so it's just the fraction from the coefficients, y equals 2 over 3. And then our third scenario for horizontal asymptote is that it's bottom heavy. And we see that the bottom, the denominator, is raised to the third power, the numerator is raised to the second power. So this is a bottom heavy scenario. The larger number is on the bottom for the exponents concerned. And so what that means is, again, you do have a horizontal asymptote, but it's the equation y equals 0. No math to be done. When you see the bottom's larger, y equals 0, which is the x-axis. And so if you had a quick little graph here, if we had the x-axis, that would be your horizontal asymptote, would be the axis itself. The x-axis is the equation y equals 0. The y-axis is the equation x equals 0. So those are your three scenarios. If the top's heavy, no asymptote at all. If it's equal, it's simply y equals the fraction of your coefficients. If the bottom's larger, then it's y equals 0, the x-axis. And that's about it for horizontal asymptotes. So let's look at an example now that we'll do start to finish, where we go through all the steps we've covered so far in this chapter. So I'm going to find the domain. I'm going to find the vertical asymptote, any holes in the graph. I'm going to find horizontal, all that stuff. So step one is factor the numerator and the denominator. The numerator has a GCF. I could take that out. I get 2x minus 3. The bottom denominator, dots. X plus 3, x minus 3. Now these numbers down here would end up giving me that x cannot equal negative 3 and x cannot equal positive 3. Now this is going to cross out. So this is a vertical asymptote, the one that's left over. The one that gets crossed out, that we end up with x cannot equal 3, that is going to be a hole. So let me first continue what I had up here. Once I cross these out, I should rewrite my rational expression as 2 over x plus 3, with the x minus 3's crossing out. And then let me kind of create a list over here. My vertical asymptote is the thing that didn't get crossed out, this x plus 3. That comes out to give us a vertical asymptote, that x cannot equal negative 3. And we do have a hole because we had a term cross out, the x minus 3. And remember, the hole is a coordinate. It would be 3, which we get from this, like solving the x minus 3, just like we would if it were an asymptote. The y value comes from substituting that value of 3 back into the remainder of the equation, so replacing x with our x value, and so that is 2 over 6, which is 1 over 3. So your hole is going to be located at 3 comma 1/3. And both of those are related to our domain, so now is a good time to start to state the domain, that I have restrictions for my domain at the vertical asymptote and at the hole. So both of those x values are involved. And so I'm going to go from negative infinity to negative 3. All x is everything between that, but it's not negative 3. It's all the numbers between negative 3 and 3, but not negative 3 and 3, just all the numbers between, and all the numbers between 3 and positive infinity. And so the last thing, the thing that we added today, is a horizontal asymptote. And so we can state that now. And we're comparing our exponents. The highest exponent of the numerator is 1. Highest exponent of the denominator is 2. This is bottom heavy, so it's y equals 0. If it were top heavy, it would be none. If they were equal, it'd be a ratio of these numbers, which would be 2 over 1. But it's bottom heavy, so y equals 0 is the equation of the horizontal asymptote. That's it. See ya.